Okay, now, welcome to today's lecture. Today's lecture is named as Miscellaneous because I'm going to cover 3 topics today. We don't have much time left, so on this Friday, the class will be cancelled. The class on Thursday will be cancelled because I have to do my own projects and I have to graduate very soon. So forgive me, I have to spend more time for the work of myself. And in this lecture, I will talk about 3 things. Actually, I wanted to put them onto several different slides, different lectures in the beginning, but now I'm combining them. The first one is how to get free network data easily. The second topic is about modeling intersection, traffic signals. The third topic is for the simulation of pedestrians. There are different topics. So let's go to the first topic of the day. Where do we get free network data? When you are modeling, when we are doing a simulation, the first thing you want to get is the network. You want to build a network from scratch. And one thing you can depend on is this project called OpenStreetMap. If you go to this website, you will find a lot of free things. And this site is for collaborative mapping, and it's created by this person in 2004. So if you go to the website, openstreetmap.org, you will find this interface, which is very similar to Google Maps. Here is a search box. If you type your address here, you will be able to search using this interface. And pay attention to this part. Here is a button called Export. So if you go to Export, then here you can specify the longitude and latitudes, which is given by the area you select. And you specify the longitude and latitude, and here you choose a format to export. You choose this one, XML data. Then you click Export. So you choose a region, choose an area, and you export the map. The exported map will be an XML file. And this file, if you open it using Notepad++, it will be like this. But it's highly structured, highly organized, so it can be recognized by other applications. So you go to OpenStreetMap and you download the map, XML, like this. The next step, you want to use a tool called eWorld to view it. eWorld is a tool to import the network data from OpenStreetMap, and you can visualize, edit, and enrich the network data, and you can convert the network to Sumo format. Sumo, do you remember Sumo? A tool that I introduced in the beginning. So you use this free tool, eWorld. In order to install eWorld, you may want to install Java first. It's depending on Java. Install Java. Then go to sourceforge.net and search eWorld. And then you click the Files tab and download the latest version. Then you unzip the file and run eWorld.bat or eWorld.sh, depending on your operating system. And this is the interface of SourceForge. And one of you had a problem downloading transients because when you search eWorld, you will be redirected to a page with this tab, Summary, open. But you want to click this tab, Files, and then browse all the files here and download the latest version. Now, if you run eWorld, you will find this interface, and you click Import and choose Import from OSM file. Then you will be able to view the file you just downloaded. This is the interface of eWorld. So you can see everything here, and if you double-click any element, you'll be able to see its attributes. And for example, here is the attribute of a street that I just clicked on. For example, it has 1 lane, and it has a priority and maximum speed. And then you will be able to check all the traffic light, all the signal information by this traffic light editor. You can view it. But this tool, eWorld, is very crude. In case you want to edit your network, it won't be sufficient. So you need another tool, another free tool called JOSM. It's a Java OpenStreetMap editor. Similarly, you download this thing from this website, and if you run it, if you use JOSM to open the file we just downloaded, you will see a more complex interface, and you will see more features you can use. So if you want to edit your network a little bit, sometimes you would want to add a link, sometimes you want to remove a link. In these cases, JOSM is enough for you. And after modification of the XML file, you will have to use eWorld to convert this OSM file to Sumo format. And you can use the export function to open a dialog like this, to export to Sumo. And here you specify the output location and output name, and you check this box to generate the network file. You have to locate one file in Sumo. So let me go to the next page. This is basically the upper part of the dialog. So here you have to locate a file called netconvert.exe, which is part of Sumo. So if you download Sumo and you extract the zip file, you'll be able to find this exe. After this, you can click export, and then you will have a Sumo network. Then you can view it in Sumo. Let me show you how these files look like. After converting, for example, I converted my map to Sumo. I specified a name called net. Then I generated a series of XML files. The first one is called node.xml, and this file consists all the information of nodes. So if you want to see all the node information, go to this file. And another file called edg.xml. This file is about all the edges or links. The third file is .net.xml, which has all the information of like traffic signals or priorities, all things like that. So by converting these three files, you can create any network you want in your simulation tool. If you want to create a parametrics network, you can just convert this, write your own program to convert these into parametrics. This is not very hard. I have a tool immediately available to convert this into parametrics, which I wrote on my own. And I think these XML files are very easy to parse, to convert. So that would be a beginning. So if somebody asks you, or if you want to create a network or simulation model of some area, just use this methodology. Go to OpenStreetMap and edit the downloaded, export the network first and edit the network, and then convert it to Sumo. And these Sumo files are very easy to edit than the original XML file. All right? So that's my recommended approach. Through this approach, you don't have to pay anything. All you have to do is to write a program for conversion. And if you need a program to convert this to parametrics, you can ask me for it. Or if you want to convert to vSim, I can give you the source code for free. Okay, so that is the first topic. I introduced that very quickly. Do you have any question about that? Have you encountered any problem when you are doing your current project? Do you have any problem? No? Okay. So let me quickly jump to the second topic, which is traffic signal. Traffic signal is not the content of this class. It should be taught in Adele's class called the Traffic Operations Design. So in this class, I'm not going to teach you the same thing that you have already knew, but I want to focus on something that Adele may have not taught. So anyone knows what it is? This is called semaphore. This is the earliest traffic signal, which was used in 1868 in London. Do you think at that time there was any car in the world? No. These things are used for horse-drawn cars. They are not used for the motorized cars. But these are the earliest traffic signal. So you see here are two arms. If these two arms stick out, that would mean stop. If they don't stick out, that would mean go ahead, not stop. And at night, first of all, there are some officers holding it manually. So at that time, there was no computer, you can imagine. So there were people holding it. And at night, there was a glass light at the top. When this light was lit, there are two lanes for indication. A red lane is for stop, and a green lane is for go. So that was the earliest traffic signal. But for formal traffic signal for motorized cars, we can date back to the 1920s. So the earliest traffic signal is called traffic tower. And the officers inside the towers operate colored lights or semaphores, or just wave their arms. And do you know the earliest city in the US to use this traffic tower? Can you imagine? This city, I think, has currently been almost deserted, but it's a big city called Detroit. Detroit installed the first traffic tower in the US, and it became the first city to use red, green, yellow lights to control traffic signal as early as in the 1920s. Now let me show you what a traffic tower is like. This is a traffic tower. There is an officer, maybe more officers in it, and they control the light. At that time, there was no computer. There were no computers. A Detroit police officer named Potts, William L. Potts, invented this traditional four-way, three-color traffic signal. So we call it Potts signal. This was a very early thing. So this is a precious picture. After that, since 1935, this traffic signal had been standardized by this book, this manual. This manual is used very frequently in traffic simulation, traffic engineering. It's called Manual on Uniform Traffic Control Devices, whose acronym is MUTCD. In an early edition of MUTCD, the modern lights had been standardized. In the beginning, they used 4-inch lenses. In modern days, they use 8 inches or 12 inches lenses. And in the beginning, they were using incandescent light bulbs, which consumes a lot of electricity, but now they changed to LED, which consumes less electricity. But basically, the idea of four-way, three-color signal was standardized in 1935. So that's the brief history of traffic signal. Now let's go to a more academic part. So let's consider an intersection. Let's review some concepts in traffic that you learned. So we have intersection. We have a major street or main street, eastbound and westbound. We have a side street, northbound and southbound. And we created 4 phases